Welcome to the Machine Room Podcast, bringing you conversations at the heart of data centers and AI infrastructure, unpacking the technologies, energy systems, and innovations shaping our digital future. I'm Kevin Brown, SVP and CMO for data centers at Schneider Electric. And in today's episode, I'm joined by Anuja, who is the Emerging Technologies Executives at EPRI. Together, we explored her journey in the energy sector and why speed to power is becoming a critical competitive advantage, how greater flexibility could help unlock access to power faster, and why the grid is struggling to keep up with AI's unprecedented energy demands. We also discussed why aligning utilities, data center operators, and technology providers is critical to supporting the next wave of AI innovation. Let's get into it. Hi, Anuja, welcome.
Thank you, Kevin.
Why don't you tell me a little bit about yourself? Why don't we start there?
So I'm Anuja Ratnayake. I am part of EPRI, the Electric Power Research Institute. And my day job these days is to do the DCFlex project, which looks at data center flexibility as a grid resource for powering AI.
So you're in a very interesting role. Maybe just explain a little bit more about EPRI, DCFlex, and kind of what is that organization, why does it exist, and some of the things you're addressing.
Sure. So EPRI's been around for about 50 years. We are actually around 54 years old right now. We are a nonprofit. We are unbiased. Our focus is creating societal value through scientific research. About 2 years ago, it was brought to our attention by our board and our EPRI's membership that we were seeing a uptick in data center-driven load. And we saw this potentially accelerating at a pace that we weren't necessarily seeing prior to this. That was the point in which our board essentially guided our leadership to have a conversation about how much of this growth is real. Is it coming at the pace it is being perceived through the interconnection queues in particular? And is the scale of the individual loads truly accurate? Because what we were seeing was something we had not seen at this pace and scale prior to the last 24 months. That was the point at which EPRI got involved in looking at what is required to power the AI evolution that's coming at us.
Okay, so that's 2 years ago. So I want to get into that in a little bit of detail. But before we do that, why don't you tell us more about your background specifically?
So I grew up in the utility industry for about 2.5 decades now. I started straight out of graduate school, joined Synergy, which was based out of Cincinnati, Ohio. And then Synergy and Duke Energy merged about 2 years after I joined the company. And I've been with Duke for till 2024. So for good 20 years, I grew up in the utility industry. I did everything pretty much that you can imagine that is a strategic role inside the utility industry over those 20 years. Everything from corporate strategy to looking at emerging technologies. Energy storage was one of the very first emerging tech I worked on in like 2007. That was the point at which I got introduced to EPRI. I was a member with EPRI as a industry practitioner for a good 15 years there. And then towards the end of my time with Duke, I decided EPRI would be a great place for me to make a different type of a difference.
So the opportunity to work on research, innovation, and then how do you get these people to collaborate, which is always easy and straightforward and never a challenge, I'm sure, correct? Especially utilities.
Well, so with DCFlex project, when we start talking about it, we have 70-ish members right now. And it comes from not just even the utility industry, which is our traditional membership. It's utility industry, the data center industry, the tier 1 technology industry. Everybody needs to come together to solve this once in a lifetime challenge we have, right? It's kind of exciting. It's by no means easy, as you sarcastically put there, but it's one of those opportunities in many other roles you don't get to work on. And even if you get to work on making it successful, it's not possible to make it successful without this kind of collaborative. So It truly is like one of those dream jobs that you can't really complain
Yeah,
about.
yeah, that's fantastic. So let's get back to the story we were saying is, for years, EPRI's existed. It's been working with the utilities, and then all of a sudden the AI boom hit the radar screen, for lack of a better way of saying it. So talk about some of the challenges. Let's dive into a little bit about from the grid perspective, what you're seeing, from EPRI's perspective, what needs to happen.
Right. So when it all started, it took us a hot minute to figure out what was the actual challenge. And what we learned was the data center industry has been there for a good 20 years. So we had a sector called data centers when we were doing load forecasting, for example. But what we are seeing as what's coming from the data center industry over the next 5, 10, 15 years is not the same data center industry we saw for the last 20 years, right? Part of it is purely the pace and the scale it's growing. So what used to be 5 megawatt loads to 100 megawatt loads, now suddenly it's a single facility that is 500 megawatts, a gigawatt, or multiple gigawatts. We are now suddenly thinking about a grid that grew through the masses over a 100-year period. A city that the grid serves today is represented by a single node now.
Yeah.
So the difference in the physics of serving that load, that has to be taken into consideration. And that's part of the reason that everybody was coming to the table and going, wait, this is a different challenge.
Because
And
it's not only the capacity, it's also the density that you've got, I assume. Is that a good assumption or bad?
so it is, when you think of the system topology, serving one node that is a gigawatt versus serving a entire distribution system like a city with that same amount of capacity, you have to consider different elements, right? So there is that portion. The other piece is data centers came to this conversation with the 20 years experience they have, where when they raised their hand and said, I want to be connected to the grid, they were generally able to get connected to the grid within that 2 to 3 year time horizon.
Right.
But now suddenly when you're a gigawatt scale load, the grid has a responsibility to serve you, but the grid also has a reliability mandate that they have to comply with. And that reliability mandate is everybody I serve, my standard offer is 24/7, 365, 5 nines reliability. In order to serve a gigawatt scale load at any given point in the US grid in particular, you are going to have to do significant infrastructure upgrades.
Right.
Those significant infrastructure upgrades cannot be done in the 2 to 3 year window. Remember, when it was 200 megawatts, there were pockets in places where you could unlock 200 megawatts within the 2 to 3 year window without getting a brand new transmission line built, right? You can no longer do that when it's a gigawatt scale. So now you're suddenly looking at immediately a 7 to 10 plus year planning horizon and construction horizon and permitting horizon in order to serve that same load. That's where the mismatch was. The data centers came from, I grew up in this environment, this is my expected time to connect. And the utilities were like, okay, for me to meet you with the same level of service that I promised everybody else, I have a few extra steps to get done. And that few extra steps creates a few extra years in the interconnection process. That was the fundamental challenge that we were asked to sort of get involved and help navigate. Once we understood that challenge, the immediate answer was, okay, when I look at the entire equation and all the variables in front of me, there is only one variable that I can actually work with, and that's that service agreement.
Right.
So instead of 24/7, 365, what if it was 24/7, 200? And I'm really just using it as an example, right?
Yeah.
If I can change that service agreement, there are pockets that has some amount of capacity available that can be unlocked in the 2 to 3 year time horizon. That is what we termed as flexibility. So in traditional sense, don't think, like I tell everybody, don't think of this as a demand response program. There are nuances that are very different. Think of this more as a non-firm interconnection. So a firm interconnection comes with the 24/7, 365, 5 nines. A non-firm interconnection is something other than that. That was the starting point of the mindset for DCFlex. What that then told us from a research point of view was there's two big research agenda items. First one is, can these data centers actually be flexible assets? Could they operate as flexible load and be a grid asset? The second part was, we've never had this kind of a load at this scale that would be a grid asset. There is many parts inside the utility industry that has gap areas in order to embrace this, integrate it, and continue to operate the whole grid with the same reliability and affordability commitments we have, right? What are all those gaps that needs to be addressed? So that's what under the umbrella of DCFlex, that is the big two research questions.
Those are the big questions. So just help me understand this a little bit more. So you're at EPRI, right? You see this 2-year thing. You look at it and say, okay, guys, 7 years, right? And I'm sure all the data center providers were ecstatic to hear that, right? Because they're trying to deploy in 6 months or what have you. What I hear you saying is that EPRI started facilitating a conversation about, okay, data center guys, if you start changing the way you behave and can become a little bit more flexible in your business practices or how you interact with the grid, because every data center, as you know, can run offline. I mean, they have backup power, but generally speaking, historically, they weren't willing to utilize that. Right? For various reasons that were very business related, environmentally related. There was always a good reason. Is that the type of thing that you're talking to them about? It's like, hey, if you guys change the way you think about how you interact with the grid, that gives us more flexibility and a better chance to meet some of the big requirements that you've got. Is that am I getting the right?
So that became one of that, when we talked about the two big research questions, that was one of the big questions, right? Yeah. How do you unlock flexibility? Initially, I said flexibility, and every data center operator was
crazy.
Like, no. But then it was a function of understanding, why are you saying no? Because to your point, all of you have backup generation. Why are you saying no? Now, traditional backup, which is tier 2 diesel, cannot be grid parallelly operated.
Right.
So that itself has challenges, but then
But they're all moving more towards gas turbines now.
Well, so the conversation there was, it's in your design. What is stopping you from changing it from a tier 2 to a tier 4, from a tier 2 diesel to a tier 2 HVO? Like, your technology options exist as long as in your design there is a place for on-site power, right? And that was the point when things started clicking with the data center community, when we started talking about flexibility as not demand response. Because if you think of demand response, normal demand response programs are like, here's a lighting
Explain demand response in case people don't know what that is. Yeah.
So demand response is a traditional utility program that essentially looked at bringing capacity in short windows of time as a resource to the grid. Now, that's going to sound almost exactly like what we are trying to do here. The issue with demand response came from sort of two aspects. One aspect was demand response programs were primarily tied to technology solutions, meaning lighting or HVAC systems, right? Data centers had no interest in anybody else coming and touching component pieces inside their design, because their design itself is complex and it's part of what is proprietary to their competitiveness.
Well, and their interest is 100% uptime reliability to keep the data center running.
Exactly.
And so they're not interested in taking any risk for demand response, traditional demand response programs.
And then the second problem with the demand response was the incentive structure for demand response that is tied to the avoided cost mechanism. These are terminology that really doesn't matter all that much, other than to say avoided cost incentive structure is going to look like pennies to the revenue that would have to be foregone for a data center to participate in. So we had to understand the data center's motivation as to why they are even having a conversation about being flexible.
Well, it's interesting that you bring this up, because data center industry for years has talked about the cost of downtime.
Right.
right? But if you believe what Jensen Huang and NVIDIA is saying, is now they're saying, hey, the difference between a data center and an AI factory is an AI factory is generating revenue because you're selling tokens. So that makes that conversation even harder, because unless there's a pretty good return for a demand response program, my interest level is very, very low unless you're going to give me a much bigger return than the utilities are able to provide.
When you think about making the business case, if the business case was to be made, you take down your operations and I'm going to pay you the grid avoided cost.
Yeah.
That's not a business case that's going to pan out.
Okay, so 2
But-
years ago, this pops up, right? So for years, this conversation's been going on. All the data center guys say, I have no interest in being interactive with the grid.
With the
So
exception,
you started changing this, right, through EPRI.
well, with the exception of Bitcoin mining, they always participated, but their economics is different, right? So let's go back to your example about AI factories, for example, right? The math is not going to work out if that is the conversation we are going to have about a business case.
Right.
But the math works out if you think about it. Why are data centers talking to me? It's about speed to power. It's the how fast can I access. The fundamental economic driver there is not about making the marginal revenue in an hour. It's about the opportunity cost of not having access, period. Right? So now it's a different business case you're doing. You're doing the business case based on the opportunity cost of being able to be up and running at 24/7, 200 hours, instead of having to sit there and wait all 365 days for 7 years.
Right. So
Very different.
let me give you that. So you say, I'll get you up and running in 1 year if you have some flexibility in your design and the way that you interact with the grid. Or it can be 7 years if you do it the old way.
Right.
So in other words, what you just gave me is 6 years of running AI factories and selling tokens. So
5
that's
to
the
6
math.
years. Exactly.
Right.
That
So
was
that's the difference that's happening in the industry now,
Right.
from your perspective.
Well, that was one of the mind shift differences. The other mind shift difference was going from I'm going to dictate to you when to shut your workload, when to stop doing your computing, to saying, I'm going to give you a direction, like I'm going to give you a signal that says when you need to come offline. But what that means is inside the fence, you can design how you come offline. You have many flexibility options inside the fence. It's not just compute. You have the compute workload, you have an auxiliary workload, but to your point, you also have on-site power. Design this appropriately, you can be flexible.
So what I'm hearing from you is look, the technology is there to make this all happen, right? EPRI is in the midst of driving the collaboration between the utilities and the data center providers.
Right.
So that's a very positive sign that the data center industry is going to be a positive impact on the grid. So I'm sure all the questions are answered, and you kind of mentioned earlier, there's still some gaps. So what are some of the gaps that you still need to work on?
So the questions that have been, and DCFlex is a 3 to 4 year project. So by no means are all the questions answered, because we've been going at it for less than a year so far. From the gaps perspective, what we have been able to answer is understanding the motivations, understanding how to create a common language to talk about what does flexibility mean. So we just rolled out Flex Mosaic. It's a framework to explain what flexibility is needed, where, and how to achieve that. It essentially creates that environment. Outside of the flexibility piece, these data centers also introduce grid reliability challenges. Remember, we started the conversation with this is a single load that is the size of a city. There is reliability challenges both from right through requirement side, but also that is created particularly by the AI training workload shapes.
Yep.
Those are things that has to be addressed through the interconnection requirements and grid code requirements. That's an area that is emerging right now. Many entities are working. EPRI is working with those many entities like NERC, for example, over here in the US, to understand how would we come up with mechanisms to address that reliability challenges. In addition to that, there are many other challenges. At the end of the day, there is some concern about the affordability implications here. There is many concerns about community impacts. There's many things we have to work on to now take even this flexibility piece that we talked about as we've had great success come into a good place. You still need lots of tools, lots of operational practices that needs to get back into both industries to truly operationalize this, right? All of that is what we need to get done in like the next 2 years in order to truly realize the goal of the AI, the data center industry, to realize their growth without jeopardizing the reliability and the affordability commitments the utility industry has to society at large. So,
But I guess what's good news about this is, yes, there's challenges, right? But you've got the right conversations happening with the right people, and they're proactively working on it. And there's the incentives to solve these problems.
right.
They're there.
Exactly. This is one of those challenges that only happens maybe once in a generation.
Yep.
And really, with the 20 years of experience I've had in the industry, I don't think we could have had a better partner than the data center industry to face this challenge and truly like innovate for the future. On one side, they have innovation in their DNA.
Yeah.
So they're not scared to rise to the challenge. And they're truly leaning in and trying to go on the journey as true partners instead of sort of being adversaries and asking for the everything under the sky kind of thing. So really, yes, it's a challenge, but it's a good challenge that brings the right parties to.
And I think the other good news is it looks like you have great job security, because there's plenty of challenges and gaps still yet to address. So thank you very much for taking some time and speaking with us today.
Absolutely. Thank you, Kevin. It's good to be here.